So right now, the different types of printed electronics or different types of printing systems are all of these. The red ones are actually very digital. There's direct write, there's thermal transfer, there's actually emerging technologies where they're printing 100% metal, they're molten metal. There's a technology which is really interesting called aerosol jet, and that takes ink and aerosol jets and it can print lines down 10 microns. So with microelectronics and everything trying to get smaller and smaller, that's a really cool technology. Not only that, it can print on 3D objects. So you can take an object like this and it uses something like a 5-axis CNC machine and we'll be able to print circuitry right on top of an object. What are our goals here? Well, imagine a drone and you have a lot of ribbons and a lot of electronics. Imagine it all being printed all at one time, an arm of a drone or something of that nature. One of my partners actually was hoping before he exited the company that someday we will print a whole airplane. I was telling him it's kind of foolish at this point, but that was his desire. We stood with aerosol jet and inkjet, mostly inkjet. The reason inkjet is why we stuck with inkjet is because it's got multi-channels. You can put different materials. So a regular 3D printer, how many of you have 3D printers at home or worked on 3D printers here? They all print with generally just one material at a time. So you can make a Lego toy. You can make all sorts of valves, mechanical items. You could but adding multiple materials, some of these bigger additive machines could do that. You now have a variety of things you could do all at once as you build. So we knew that inkjet was going to be the way that we're going to be able to do additive manufacturing of electronics. And so that's where we headed and strove to go into inkjet. So the benefits of printed electronics over traditional methods: fewer materials, less energy. The design and development aspects are faster. You can have an additive manufacturing electronics printer sitting on your desk while you're at work. Make a prototype design, which would normally take, if you take a design, send it out, have it done 4 to 6 weeks. You can get it faster if you pay a lot more money for it. It costs thousands of dollars to do. Instead, you have a printer sitting on your desk and develops, and you can check out your design right away. So while we were at the Energy Center, there was another company right next to us that was converting EV UPS trucks to EV. You're probably familiar with the company. But they once asked us, can we print a circuit for them? They needed it real quick, and we went ahead and did that, and we placed the components on it, gave them the circuit, the PCB board right away within 24 hours. The next morning, they came to us and said, well, we kind of messed up on our design. Can you reprint it? We had 10 boards for them right away. We messed up on the design. Sure, give us the next design. We printed that for them. Within, that same day, they had the 10 more boards that were functional at that point. That took 2 days. That would have been months and months and large expenses on their part that we were able to do in just a couple of days and help them out. That was a good proof of concept for us of what we're capable of doing. So, and that was about 8 years ago, 7, 8 years ago. We've expanded quite a bit. So what I'm saying is a lot of parts of the design aspects, the designers in engineering are, so I'm talking to engineers from Boeing, from Lockheed, and they are re-engineering or redoing the designs in a manner that could be additively printed as opposed to traditionally developed circuit